Good evening, ladies and gentlemen. I'm glad you all are here with us tonight. Now, before I start off my speech, I would like all of you to think of something. How many of you have interacted with something made of plastic today? Indeed, plastic has become an inseparable part of our daily lives. We use plastic in transportation, commerce, delivery, dining, and countless other different contexts due to their unique and stable properties. In fact, the initial aim of the large-scale utilization of plastic is to ease deforestation by acting as a replacement material for paper containers and bags.
However, despite the benefits that plastic has brought forth to humans, and just like almost any other thing in life, it has its negative sides. Plastic, unlike stone and paper, does not have a natural cycle of its own. To be more specific, it cannot decompose like rocks into soil or like paper into carbon dioxide and methane, but stay in this form for over centuries, if not millennia. Well, burning plastic seems to be the most intuitive way to address this problem, but more may arise. As plastics burn, they release toxic substances such as sulfur dioxide, dioxins, and heavy metals into the atmosphere, making it deadly when inhaled.
Instead of continuing to ignore this problem, I would like to propose several solutions. One is to substitute plastic with other materials, and the other is the incorporation of biodegradable plastics. Now, imagine substituting plastic with another material. Some would definitely feel that doing so would retract all of the benefits plastic has caused to easing deforestation, and it is certainly natural to associate an increase in paper-based products with an increased amount of trees being cut. Well, in fact, paper is actually one of the most sustainable resources that humans use today.
According to a 2016 article by Our Auckland, paper can usually be recycled 4 to 6 times before its tissues become too weak.
Glass, on the other hand, may be more costly, but they're certainly more environmentally friendly as they can be recycled into lots of other usable products and will not lose any quality upon recycling. The second solution that I propose is biodegradable plastics, the topic of my speech tonight. Biodegradable plastics are able to naturally decompose into harmless substances such as carbon dioxide and water and are usually made of organic material. This makes them especially advantageous when compared to conventionally made plastics, which are usually derived from crude oil and other fossil fuels. Now, I know that after listening to some of the speeches that my classmates have made tonight, you may be concerned that this process will further intensify the greenhouse gas effect. However, the aim of biodegradable plastics is to shift towards a green way of production, where the carbon dioxide released upon decomposition are chemically changed back to the building blocks of those plastics through a series of different reactions. This would ensure that this whole process will not worsen the greenhouse gas effect, even when operating at a larger scale. Implementing this inner life cycle of carbon through the plastic manufacturing process is a huge step towards global carbon neutrality. One example of biodegradable plastics is polylactic acid, or PLA for short. And no, I do not want to overwhelm you with long, nasty words that are useless outside of the field of chemistry.
PLA, by its name, is simply chains of lactic acid molecules that are formed from the fermentation of cornstarch. They perform similarly to conventional plastics and have a wide variety of applications, from disposable kitchenware to different kinds of packaging. It can also be used for compost bags and floor mats. Most importantly, it can be used as medical implants, such as screws and plates during surgery or therapy. In addition to medical implants, they can degrade inside one's body back into lactic acid molecules after a period of time and can be easily metabolized out of your body.
Certainly, if PLA was that effective, why do we not see it all around the world today? The truth is, PLA can be quite brittle and have rather poor mechanical properties and do not withstand well against intense heat. This means that its scope of application will be limited. Furthermore, the production of lactic acid, the building block of PLA, is not yet time or cost efficient, which means that the bulk production of PLA is unfortunately not possible as of today. If PLA cannot fully address the problem, governments and large corporations need to take initiative into emphasizing the importance of the innovation of other types of biodegradable plastics. Take the Chinese government during the COVID-19 pandemic, for example.
Chinese company Sinovac Biotech received a funding of 515 million RMB to invest in their development of the CoronaVac vaccine. Furthermore, mandates sent across China by the Chinese government to receive the vaccines are increasingly effective. According to Xinhua, there are already a total of more than 1 billion COVID vaccines administered in China. If governments can be just as active as the Chinese government when trying to mitigate the effects of COVID when they're looking at the production of biodegradable plastics, I'm pretty sure that we will see this change very soon.
The issue of plastic waste is not to be overlooked by humans. As some of you may know, plastic waste in the ocean have stretched down to the deepest waters of the Mariana Trench. If we substitute non-essential plastic with reusable materials such as paper and glass, and if governments encourage the large-scale adoption of biodegradable plastics by making companies responsible for their own plastic waste, and plastic will soon join the environmental friendly club and many environmental burdens can be lessened. There are always as many solutions as there are problems, so let us all strive to solve plastic waste and make this world an enjoyable place for as long as we can.